Thanks.
Okay.
So welcome everybody to, session 2BC for feedback. Lloyds Banking Group do AppDev in a dynamically created environment. It's been the end of 2 weeks and this is my finale, you know, fireworks. This is the big explosion for some customers that have actually knocked mainframe DevOps out the park. So Reg, Craig, take it away, blow our socks off.
Okay, thanks, Stuart. Hopefully over the course of the last couple of weeks, you'll have seen all the components that we're going to try and use. And my name's Reg Wilkinson. I've got a colleague on with me, Craig Coburn. And if the demo gods are with us, then hopefully we'll show you the whole thing running end to end. So terms and conditions apply. Who are we? So we are Lloyds Banking Group. Lloyds Banking Group are effectively one of the big 4 high street branches, and we have lots of brands that everybody would recognise. So my background, I was with Bank of Scotland, but we compose Bank of Scotland, Lloyds Bank, Halifax, Scottish Widows, recently acquired MBNA, Birmingham Midshires, Lex Auto Lease. So lots and lots of well-known brands around the UK. So why do we want to transform? What was the driver for this whole kind of mainframe agile DevOps experiment? Customer behavior and expectations create opportunities. So Jeff Bezos and Christopher O'Malley have got a habit of saying that customers that are wonderfully dissatisfied, and that drives change. And that is becoming more and more prevalent because customers are looking for a more personalized experience. They want to be able to interact with the bank by their channel of choice. They want to be able to start something on their phone, continue on a laptop when they get home, and then phone somebody if they get stuck. They want to be able to do that safely and securely. They want products that are more personalized. They want products to evolve and to change quickly. And those kind of desires are not what you would normally expect from a large retail bank. And certainly banks that have got a history of systems that go back for decades and that were made complex by mergers and acquisitions. That's not the customer's problem. The customer wants us to be able to react like Apple or Google or some of the new fintechs. They want us to be able to deliver things now. So within IT, how do we kind of realize that opportunity? So feature teams are the key. So a feature team is a team that is capable of doing an end-to-end customer journey. So what do I mean by that? So we will have guys who can do mobile banking, internet banking, front-end work, and they're kind of skilled in JavaScript, React, and all those kind of good stuff. They'll also need back-end engineers. Now, in large organizations such as Lloyds, the back-end tends to be the mainframe because it's performant, it's secure, it has to be capable of massive throughput, and it has to be capable of managing massive amounts of data. To do an end-to-end journey, if you were just a team looking at the front end, you could have your entire application stack sitting on your laptop. And that way you've got your entire encapsulated environment and you're not treading on anybody else's toes. You can work away quite happily. And then when it comes to time to promote your code on the live, you would have an automated pipeline and you would have automated tests and you would have code quality gateways to get through. And then you would have a consistent way of deploying your code anywhere. Now, if we wanted to do that on the mainframe, and there's no reason why not, we're just another platform, we need to make an investment in tooling. We need to make sure that our feature teams can work independently of each other. Now, we couldn't give everybody their own Z14, Z15 on the desk like we can give everybody a laptop. That's just is not feasible. And again, the mainframe physical machines are shared environments because they're huge capacity, and so lots of things can happen at the same time. So those environments tend to be quite controlled, and controlled equates to handoffs, and handoffs equates to it takes time to do things. So how could we make our mainframe environments as responsive as the development environments that we give to the engineers who are working on the front end channels? So that takes us into how can we do mainframe agile and DevOps. As a company, Lloyds have been investing heavily in their engineering tooling over the last 3 years as part of the group strategic review that is just coming to an end. And Craig and I belong to one of the teams that piloted a lot of these techniques on the mainframe. Now, we started with no tools whatsoever, and we evolved, and the team grew from 2 or 3 teams delivering in an agile way with a tool set that was growing to we're now a lab which has over 160 engineers, product owners, QAs. We are responsible for end-to-end journeys, and we needed to make the mainframe fit in with those end-to-end journeys and come up with a pattern that could scale. So that might be a scary prospect for a lot of people, but it can be done. So how were we going to do this? So we decided that the best way to look at it was to say that the Z platform is just another platform. Okay, it has its place in the bank's armory of systems, but the ecosystem that we can build around the Z platform can be a common ecosystem. So we got some guys in a room at the start of the year, and we started to sketch this out quite literally with some high-level requirements around team independence, allowing change to run at its own pace. We wanted visibility of work in progress. We wanted as much automation as possible, but we wanted the Z platform in the middle because ultimately that's where things are going to run from. What did we build in a kind of? We built from the bank's toolkit. We had GitHub Enterprise as the standard repository that all the teams which weren't running on Z were using. So we've got a broad skills base on how to use GitHub. It provided things like protection for running feature branches in parallel. Okay, we also had on the distributed side Urban Code Deploy and Nexus as binary repos. So what we could do was say, okay, in the middle, the mainframe is just another platform. If you're an engineer that's coming to us from any other tech stack, you will recognize this pattern. You don't have to care about where your application runs because everything we're going to build around your application will be standard and will be recognizable. So a lot of these things we saw demoed at GSE last year, and you'll have seen their evolution demoed in the last 2 weeks in this stream. So there are enhancements to our estate that we brought in from Broadcom. So things like GitBridge and Zowie to allow us to connect our mainframe environments to GitHub. We've got event-driven processes handling automation. We've made use of our cloud infrastructure, and we can give each of the developers a mainframe on their desk now. Not only can we give them a mainframe on their desk, we can give them a mainframe which can be spun up in minutes. So we could build one of these environments from scratch in under 2 hours. We can refresh one of these environments in 10 or 15 minutes, and we're going to demo that in a second. And this scales horizontally. So we can spin up as many of these environments as we need. So each individual feature that we're going to develop end to end can have, as well as its own front end environment, can have its own back end, and those can be completely sandboxed. So traditionally, if we were going to spin up environments on physical hardware, we'll be looking at 2 to 3 months worth of work to create the environment before it was in a fit state to use. So we've been able to reduce the 2 or 3 months to build a physical environment for system test and integration test to, let's say, 2 or 3 minutes. Craig, do you want to take us through this and to prove that it actually works?
Yeah, sure, Reg. I'll just share my screen.
I'll stop sharing.
Okay. So basically, as Reg was saying, we've now got a mechanism where we can provision effectively a containerized mainframe, and that's can be done via the Jenkins pipeline that I'm showing on screen. Now, for the sake of the demo, I'm not going to run it because it takes about 2 hours between provisioning VMs and installing the image, the mainframe image on the server. So basically, we've pre-provisioned one for this demo that's empty, but effectively within a couple of hours we can have a blank mainframe with the tooling in it and no application data. So what I'm going to demo is providing or provisioning a dynamic environment, deploying our test application to it, and then hopefully doing a quick update to that application, redeploying it back to the ZDT virtual mainframe. So the first thing that in our process is allocating a dynamic environment, and on the mainframe side we're using Endeavour. So I'll just do that just now.
So the reason we use the dynamic environments in Endeavour, and this is something that our friends at Broadcom have developed for us, is to give each team, so each team will be working in GitHub, but they will have their own route back into the mainframe. And that gives us a level of independence for each of the branches. So we're going to talk about effectively feature branches, but when we come to look in GitHub, you'll see that each feature branch in reality is a repo in its own right.
Okay, so that's kicked off the process for building our new dynamic environment. So we'll flick back into Jenkins. We've now got a webhook running that defines what they call the Git bridge, which is linking the mainframe Endeavour system to GitHub Enterprise. So that process is currently running just now. And then after that mapping's done, we'll start deploying our application to this development environment. This does take about 5 or 6 minutes to run, but effectively what it does is it defines all the DB2 tables, kicks regions, anything like that our app needs to run. So just waiting on the Endeavour Git bridge.
So under the covers, we have got a golden image of a ZDT instance, which lives in Nexus. And as Craig says, the script would spin up a Red Hat box, and then we would deploy a container with the golden image as a baseline, but we also have our application stored as code within GitHub, so all the DB2 structures, all the kicks definitions, and once we've spun up the Red Hat box, deployed the empty container. Now the empty container can be the latest version of Kix, DB2, and the operating system. So you can regression test your applications easily against the latest versions of the infrastructure without having to make changes on the physical machine. So it's things that would have to normally be planned in. We can just we can just do by spinning up an environment. So once you've got your box, Craig.
Yeah. So now the Endeavour mapping's been done, so you can see our system is called CMS, and within that it's got the various definitions for some of the components. So now the pipeline is deploying our infrastructure to ZDT. So if I just flick to ZDT just now, you'll see there's no Kix regions running or anything like that. So hopefully at the end of this pipeline, Kix should be up and our app should be working. Just now it's just creating the app, DB2 tables and indexes.
So from a dev team's perspective, this creation process is really a one-off activity they would do when they wanted to create a new feature branch. Because once you've set up the ZDT image and you've fully populated it, you can then snapshot it again and create another Docker image from your completed container. And then you only have to have the redeploy time. So you don't have to do the rebuild. So although we've said this is going to take us sort of like 10 minutes or so to build an entire environment from scratch, once you've done that, if you break that environment and you've burned through all the test data that were also pre-populated in that environment and you want to reset it, you can just kill the container and restart it from your snapshot, and you've just rolled everything back again. And because we're keeping the source outside of the container, so the source will be in GitHub, and the executables will be in either Nexus or in Urban Code Deploy. Repopulating it or throwing it away and then repopulating it doesn't risk losing something.
Yep. So just now it's created all the DB2 infrastructure. It's now just loading the application test data. But yeah, as Reg says, this is starting from a blank slate. So once this is deployed, in theory, I can create another image of it that I can use for future use. So we don't need to go through this every time. But I mean, considering how long it would have took us to set up a test environment on our physical development machine, it's really quite a big difference. I mean, you're talking within half a day, you can have it up and working by the time you provision your VM and deploy your code and everything, versus doing it on the physical machine would be, well, I'd say a few weeks to a month, depending if we get the people that we need to do the work. Okay, so the data has been loaded now, and now it's deploying our application code. After it's deployed the application code, it will start the Kix environment, and then hopefully it's ready to use. Oops. He says we had a failure.
There's always something goes wrong.
Okay.
It's when everybody's watching.
Yep. It's okay, I can skip that. It was just a DB2 bind that failed that I added at the last minute that I probably shouldn't have. But hey ho. Okay. So now I'm just deploying our Kix region to that environment.
So the idea behind using these ZDT boxes to do development is that the brakes are off, so there's no rack F unless you want it, which means that the developers can do things like make Kix definition changes. They can make DB2 structural changes, and we can get the sysprogs involved once we move the change back onto the real machine. And the idea is that we'll be able to consistently deploy infrastructure related changes via Endeavour and via the route to live. And we want to get away from having to get lots of people from lots of teams involved in deployments just because they have the authority. So we want to be able to manage everything within our application. So from an infrastructure definition perspective as well, so DB2 and Kix, everything under version control in GitHub, and then we can make it promotable in a consistent way.
Yeah, so just now what I've done is I've cloned a piece of demo code from GitHub, which is synchronized with Endeavour. So effectively Endeavour's the master and GitHub's kept in sync. So what I've done is I've cloned that down. I've opened it in VS Code. So what I can do is, this is just a GSE demo module. So what I can do is I'll change just make a quick change, save it.
While you're doing that, Craig, there is a question in the chat. Where is the environment being built and run? I'll register.
So, okay.
He said the
So now what
environment
I'm
is being
doing,
built on a Red Hat server, provisioned in the IBM cloud running ZDT.
so what I'm doing now is I'm pushing my change back to GitHub. So if I come out of this and go into find my GitHub session, wherever it's went. You can see that that was updated a minute ago. Hopefully it'll show me. There's the line of code that I changed. And if I flick back into Endeavour on the mainframe side, you can also see the change has been reflected back on the mainframe side as well. So that's Endeavour and GitHub staying in sync. So the final stage is deploying this change back to ZDT for us to test effectively. So what I need to do is I pull the application from our physical development box, pass it to our ZDT, and just run that. And this effectively copies our changed code back to ZDT. I think in the future we're going to use something like UCD or some other tool like that, but just now it's kind of doing manual copies behind the scenes. So once this is deployed, hopefully I should be able to test the amended app via Postman, because this is actually a web service API that's exposed, or adjacent API that's exposed, that's running on ZDT within Kix. Just waiting on it starting Kix back up on the ZDT. Okay. So in ZDT, hopefully, we've got a Kix region running here, which we have. I can log into it. And show you that, for example, some of our application transactions are all defined there. So now, hopefully, we've got this. Basically, what it does is it calls, this is the address of our ZDT box. The port points to a Kix region. This is our program that we changed here. And for example, this is just using a dummy card number. So if I send that, we get back the amended account name that I changed within that hard-coded value in the code that we just redeployed. So it's just really a quick demo of how within 10-15 minutes we've managed to create this environment, deploy some code to it, do a change, then redeploy the code to it. So it just gives you an idea of the power and the quickness that we can turn things around. And as Reg says, because this environment's got the brakes off, if we want to add new Kix transactions, then we can just do that. If we want to add new columns to DB2, then we can just do that. Things like that. So it's certainly been a learning journey for me, learning about all these different tools. But yeah, hopefully that gives you some idea. Any questions?
I've got one more slide to bring up before we get to questions.
Oh, you're all right. Okay.
Sorry. You can tell we've practiced this. So to give you an idea of what the technical elements of our tool chain looks like, it's a kind of multi-vendor approach. We've kind of gone best of breed where we can. So from an IDE perspective, the idea is to move away from the kind of traditional green screen, and by taking development kind of out of PDSs and into GitHub, then that kind of gets the developers to move on to the more modern IDEs. So we support things like IntelliJ, Visual Studio Code. We've got Eclipse, we've got CompuWare Topaz. So it's a weapon of choice. So all those tools all support GitHub. Because we've moved the development away from PDSs into the IDEs and into GitHub, things can be event triggered. So we can make sure we enforce things like code quality checks. We can enforce things like 4i checks and code inspections before we allow application code to merge back into the production environment. Our Docker images not only contain the operating system and database and Kix out of the box, they've also got all our tooling built in. So we've got pretty much the full set of CompuWare tools. Those all come pre-installed. So if the guys are working in the Topaz environment, then all the tools are there, and it's all plug and play. What else is worth touching on from our tooling? Yeah, so thank you very much for listening. Stuart, if anybody's got any questions, we are more than happy to discuss.
David's put a question in the chat. How are infrastructure changes, e.g. new programs, DB2 tables, reflected in the real world?
Okay, so we have got a pattern which uses effectively BMC's change man. So we've taken the DDL for the change, the tables effectively under source control. We use another Jenkins pipeline which is running change man under the covers, which will take the DDL for the tables that have been developed by the developers on the ZDT device. When we're taking it into our system test environment, it does the compare between the target and the source and works out the change definitions and applies them. Before we will take that further, so into an integration test environment, for example, one of our DB2 DBAs would then be involved in the approval process through Urban Code Deploy to say, yep, I'm happy that what the changes the developers have done is fine and adheres to our standards.
Yeah, and for the code changes, the plan is to use something like Urban Code Deploy to move it through the environment. It's something that we've got in place just yet. So currently, it would just be through the normal Endeavour life cycles.
And so flipping that question around the other way, because you said there was no RACF in the ZD&T universe, how do you ensure that any changes made on the platform to perhaps get the transaction or the application running are retrofitted?
I think that is the main thing there is going to be using something like UCD to keep it in sync.
Right, so if they make a change on the ZD&T before it gets destroyed, they'd have had to have got it on there using the deployment capability.
Yeah, so the idea is the dynamic environment's effectively got three things. So you've got the repo in GitHub for the source, and then you have all the sort of GitHub branch protection that if something has changed somewhere else, then you wouldn't be able to check that piece of code back into Endeavour until you did a pull request and accepted those changes back into the repo that was aligned with the ZDT environment. So the ZDT environment is there to provide encapsulated test environment, so you can do all your testing without impacting anybody else who's trying to develop in parallel. And at the point that we create the GitHub version for source code, we snapshot our application as well. So that will be versioned. So at the moment it's running in Nexus, but the next stage of our adventures with getting these end-to-end environments running is to effectively version our binaries in Urban Code Deploy. And so at the point we create the dynamic environment, we will snapshot that application in Urban Code Deploy as well. And Urban Code Deploy will then be responsible for moving that application through our route to live and ultimately into production. So that gives us consistency from these kind of disposable ZDT environments up to a high availability production infrastructure that we deploy consistently on the route to live.
So was that you just inviting yourself to GSE next year doing another presentation?
Hopefully it won't take us the next year to get this whole thing finished, Stuart.
Okay. So Craig answered, there was another question about Kix definitions. So any more questions, please? We have some time. Mr. Hartwell asks, what's next, guys?
What's next? Yeah, so I think from a what's next perspective, we need to go back and look and see what our next biggest blocker is. So originally it was handoffs and control of physical environments, and our our biggest constraint at the moment is the ability to scale horizontally, and this pattern using ZDT and GitHub allows us to scale horizontally. Once we've overcome this, it will be back to the whole, let's go back and re-examine the value stream and find out what our next major pain point is. Performance testing would be my guess. That's probably our next biggest pain point, is to get realistic performance testing built into our pipeline as early as possible.
Yeah, and I think also we need to work on automating some of the other testing that we're doing just now, but that's something that hopefully we can build on.
Yeah, we've got all the bits of the jigsaw puzzle. We just need to get on with gluing it together.
Mm-hmm. Has COVID slowed down the thing, or has it enforced more requirement to do all this stuff?
So COVID has been quite interesting, because it did slow us down, because during lockdown 1, the bank did go through a whole reprioritization exercise to decide which pieces of work we're going to continue that had a positive outcome as far as COVID was related. So things that, getting more contactless cards in the hands of our customers. So, for example, and this was seen as actually being a key enabler. So we got some investment focus to allow us to do this, because we are a team who do end-to-end journeys, and even if it means we could provision a standalone back end to one of the teams that are doing digital-only changes very, very quickly, so they can spin a team up to do a change on our mobile banking app, and we can give them the debit card back end in a Docker container. That means they don't have to wait for a large end-to-end environment to be available, or if we're making changes that where we do have a true feature team and we're doing end-to-end, then the guys who are making the back-end changes can't run from a technical spike perspective as fast as the teams that are making the front-end changes. In fact, generally, to be honest, we are the back-end guys on the mainframe are now more responsive.
Yeah, it's exciting for your organisation to have such flexibility available to them. You know, many organisations dream of having environment on demand. Any more questions from the huge number of attendees?
I think one thing I'd say is this is a multi-vendor solution. So we've had contributions from IBM and from Broadcom and from CompuWare and from BMC before there were CompuWare BMC. So guys who are listening to this, who are from other organizations, speak to your vendors regularly, because that's one thing that's really worked for Lloyds. And don't wait until the salesman comes around to renegotiate the contract.
Awkward pause done. Okay. Could you just show the last slide again, Reg, the one that's got the 2 BC, was it?
2 BC. There we go.
Okay, so feedback. Oh, another question from David. Is there a plan to progress this beyond unit testing?
So the plan is it's going to be for unit testing and functional testing, and then we'll move over to the physical mainframe for systems integration testing in one of our current production-like environments, if you like. So that at that point, Yeah, you've got a diagram somewhere, Reg, that shows that, haven't you?
Yeah, so we've got this concept of a release bus stop. So the moment the guys are shipping change off every month, so the release progresses every month. The idea is we want to, by using this pattern, we want to be able to turn up the gas on that, and probably next year get the speed up to every fortnight. So you deliver change from what a ZDT environment back onto the physical machine. It'll join the release bus stop, where the rest of our automated testing will kick in. So we've got functional test tools that will build up a library of effective automated regression tests, and it'll become part of the process to deliver changes to the release bus stop as you have to extend the test library. And that means that we get the code tested all the time. And then the bus will depart initially every month, and then hopefully every fortnight. And then we probably won't be able to kind of deliver change in a Amazon type time scale, so like within 15 minutes. We do want to be able to deliver change on demand, because at the moment we have a change that could effectively get moved through the life cycle in, say, a week, because it is a relatively simple reference data change, or it's a tiny code tweak to something that's off the critical path. And that at the moment does get caught up in our release pattern, which means that change could take up to 2 months to get into live. So we want change to be able to run at the pace that the change needs to run at, and not to be artificially constrained. So our physical entry point and a release bus stop, and the fact that we're going to start running this change from monthly to fortnightly, and you deliver change as a package with binaries and urban code deploy back onto the real machine, is pretty much where we want to take this next. Sorry, Stuart, I think you're about to wrap up and we went off on a tangent again.
No, it's good, because the questions, that's the main thing about people taking away the knowledge of the what you guys have been up to. And still have 14 minutes if there are any other questions. But this is the last call for questions. For everyone, this will be posted, this presentation will be posted on the GSE YouTube channel in a few weeks' time. So if you missed anything that you'd like to go over again, it will be there. And I'll remind you one more time, 2BC, Bravo Charlie, is the feedback. Best presentation award is going to be drawn later today. So from this fabulous 2 speakers, please get that feedback in for them to get a chance to win, I don't know, a piece of paper that you can cash in for some prize at some point when someone's allowed to give you something. So thank you, Reg. Thank you, Craig, for a very informative session. And thank you to all the attendees. Very nearly at the end of GSE. It's been a great 2 weeks. So enjoy what's left, and hopefully see some of you next year. Thank you.